Okay, hello everyone. I'm just going to record another quick, well hopefully it'll be quick, 10-minute or so video showing you how to run a Factorial ANOVA for the stuff we're covering in week 13. Okay, so I've got a data file open in front of me in SPSS, and it's the fearofcrime.sav data file that we will use in the week 13 lab worksheet. It's a cut down version of a real data file, and it records people's fear of crime. There are a number of variables that are recorded for this actual research, and the ones that are included on this particular file are sex, which is obviously a grouping categorical variable, male and female, anxiety, which has 3 levels. These have been coded 1, 2 and 3, you can see on this data file, and that's low, medium and high anxiety. A stress score for participants, a total worry score, so how in total how worried are they about crime, how much are they afraid of crime, I guess. And then this last variable here is constructive thinking. I think higher scores mean they engage in more constructive thinking. The only thing we're going to worry about though for this analysis are the 2 categorical variables, sex and anxiety level, one with 2 levels, one with 3 levels, and the total worry is going to be our DV. Okay, so to run this analysis, if you remember previously when we ran one-way ANOVA, there were a couple of ways to do it in SPSS. One was through the compare means option, where you can pick one-way ANOVA, or through this general linear model option. When you're doing a factorial ANOVA, when you've got more than one independent variable, then you need to use the general linear model pathway. So we select analyze general linear model, and the option we want in this case is univariate. We've only got one DV. If we had more than one DV, then we'd be looking at a multivariate type of test. So if you click on univariate, brings up this pop-up box of the type that's quite typical for SPSS. And the DV, as I said, that we're going to focus on here is going to be this total worry score. So we'll put that in the dependent variable box, and we've got 2 independent variables, and these go in the box that's labeled fixed factor. Fixed factors. So we've got 2 fixed factors. One is sex, one is anxiety level, and we move them both over to that box. Okay, so there are a few other things that we're going to ask for before we run the analysis. If we click on options, I'm going to ask for descriptive statistics, estimates of effect size, and homogeneity test. So this is an independent groups design, so it's participants only take part in one of the groups of the anxiety variable, and they're only either male or female for the sex variable. Okay, so we're going to ask for a Levene's test for homogeneity to check whether we can assume homogeneity between the groups. Okay, so if you click on continue, a couple of other things we will ask for will go. If you click on plots, we're going to ask for a couple of plots. Firstly, if you select sex and move that over to the horizontal axis, and then we click add, that will give us a plot showing the main effect of sex. If we click anxiety level, move that over to the horizontal axis, and then click this add button again, that will give us a plot showing the main effect for anxiety level. So in isolation, it will show you the main effect of sex in relation to the dependent variable, and in isolation, it will show you the main effect of anxiety level in relation to the dependent variable. The main thing we're interested in though as well is, or another thing we're interested in is the interaction between our 2 independent variables and the DV, and we can ask for an interaction plot. And the way we do this is it's often best, or it's kind of easier to look at visually and interpret if you select the variable, the independent variable with the most number of levels. So in this case it's anxiety level. We've got 3 levels, low, medium and high. If you put that on the horizontal axis and then use the other independent variable, in this case sex, where we've got 2 levels, male and female, use that as separate lines, and if you click add, it will show now we've got an angs level asterisk sex, so anxiety level times sex. So it'll give us a plot for the interaction between those variables. Okay, so if I click continue, before we run this, There's one other thing, or a couple of other things in fact, that I was going to select. If you click on estimated marginal means, we can select all three of our variables and move them over, and this will give us a couple of things. It'll give us descriptives, but what I'm also going to ask it to do is compare main effects and make a Bonferroni adjustment. So it's basically it's going to do pairwise comparisons. So it's going to do what we could say really post hoc tests on the main effects for us should we need those. We can click continue, but we can also ask for post hocs separately. If we click on this box, post hocs tests, and if we ask for post hocs, the only one we really need that on, if we find we've got a significant ANOVA result, sex has only 2 levels, so if we get post hoc tests for sex, we don't really need them. If we get a significant ANOVA for sex, we can just look at the table of descriptive stats and look to see which is the higher mean. Anxiety level now has 3, so we could also ask for post hoc tests for that particular, separate post hoc tests for that particular variable with 3 levels, and then that'll do those adjusted comparisons to control for type 1 error for us. So there are a few we can choose from. We could do Bonferroni. If I click Bonferroni, it'll give us the same output really as the Bonferroni adjusted estimated marginal means. But let's say for argument's sake we did want to select another post hoc test, let's say Tukey in this case. Notice actually though that the equal variance is not assumed options are grayed out. For some reason when you're using the general linear model pathway in SPSS, it won't allow you to select one of these more robust post hoc tests. Not sure the reason for that, but I think that what you would have to do if you needed a more robust post hoc test, if you couldn't assume equal variances, what you would need to do is basically run your analysis again, but use a one for your post hoc test for whichever variable it is, like where we're just doing a post hoc test for anxiety level. So effectively we're doing a one-way ANOVA on with some sort of type 1 error adjustment on a single IV with 3 levels. So I think if you needed a more robust post hoc test, what you'd have to do is run the analysis again, but run it using the compare means one-way ANOVA option and select something like games how. Okay, so if I click continue, I'm then going to just click OK, and that will give us the usual huge amount of output that we get with SPSS. Let me make this bigger, the output screen. Okay, so lots and lots of stuff here, tables of descriptive statistics, Levene's test, the ANOVA summary table, and then the estimated marginal means. It's given us descriptives and comparisons for, firstly for sex, secondly for anxiety level, and thirdly for the interaction. Okay, and then we've got the post hoc tests, additional post hoc tests that I asked for, which was the Tukey's honestly significant difference. And then the last thing we've got is a load of plots for the main effects and the interaction. So let's kind of walk through these results a stage at a time. So the first thing we're going to want to do is look to see if we can, in this case, assume homogeneity variance, assume that the variability, the variance between each of our groups is roughly the same, it's roughly equal. And remember, we want it to be. We want to assume, we want the variance between around each of the group means to be roughly about the same. So then we're comparing groups of roughly equal variance, and if there are differences between the group means, we should be able to detect them more effectively. Okay, so to answer that question, we'll look at Levene's test. We can use based on the mean, and in this case we get a Levene statistic based on the mean of 1.883. So basically, I've said this a few times now, but what Levene the Levene's test has done. It's done a ANOVA test, an F test, comparing two things, comparing two groups. One, a null hypothesis that the variance around the groups is the same, compared to an alternative hypothesis that the variance around the groups is not the same. And if we get a non-significant result, we can assume that the variance is the same, which is something we would like. If we get a significant result, we can't assume that. We would have to use some other adjusted and more robust statistical test. But in this case, we get a Levene's statistic F value of 1.883 and a significance p-value of 0.098. So it isn't statistically significant. So it suggests that we're probably safe to assume homogeneous variance. We can assume that the error variances between the different groups are roughly equal. Okay, so that said, we know we can now go on and interpret the results of our ANOVA. So if we look at the test of between subjects effects, this is our ANOVA summary table really. And what it gives us is, it gives us three F ratios that we're interested in. One for the main effect of our first independent variable, another for the main effect of our second independent variable, and a third for the interaction between our two independent variables. So in this case, our first independent variable was sex, and we can see from looking at this table that we get for sex, if we read it from along the line here, along this row, we get an F value of 32.34. P is less than 0.001, so we get a statistically significant main effect of sex. The second independent variable was anxiety level, and that has a row on its own as well. Angst level, we get an F value of 4.173, and P is equal to 0.017. So we've also got a statistically significant main effect of anxiety level. Okay. The third thing we're interested in is the interaction, sex times anxiety level interaction. Okay, so this will tell, if we get a significant interaction, it will tell us that the effects of our two independent variables are not additive, and that there's probably something different going on at one level of one independent variable when you combine it with the other independent variable. Okay, in this case though, our sex times anxiety level interaction, we've got an F value of 0.782 and P equals 0.459, so we don't have a significant interaction. So this makes life easy in this case for us, because where we don't have a significant interaction, we've got two simple stories that we can tell. In this case, it is two simple stories because we have two significant main effects. And we could report, if we were reporting these results, we would basically report we had a significant main effect of sex, a significant main effect of anxiety level, and a non-significant interaction between sex and anxiety level. The non-significant interaction means we can ignore that effectively. We don't have to do further testing to try to pick apart the interaction, and we can just look to interpret the main effects. So in the case of sex, we know we've got a significant difference between males and females, and because we've only got two levels, what we can do is look at the kind of marginal means or just the descriptive statistics, and what we find is for males we've got a mean of 1.69, for females a mean of 2.198. So what we'd be able to conclude from that and write in our results is a significant main effect of sex showed that females had significantly higher total worry scores in relation to fear of crime, with a mean of 2.198 compared to males with a mean of 1.69. Okay. Our second significant main effect, though, anxiety level, is a little bit more complicated because it has more than two levels. It's got three levels, and so we need to compare that. We need to look to see where the differences are between those three levels, whether low is different to medium, whether medium is different to high, whether low is different to high in terms of anxiety, whether those are all significantly different or just some of them. So we need to do some sort of corrected post hoc tests. And in relation to that, where we asked for marginal means comparisons, we can answer that question by looking at this pairwise comparisons table. We've seen these a few times now. We've got a table of means above it that shows, it looks like so it is definitely the case that the lowest, those with low anxiety had the lowest mean total worry in relation to fear of crime. Those with moderate had slightly higher than them, 2.023. Those with a high anxiety level had a higher total worry score in relation to fear of crime, 2.055. Okay, so we know what we need to do is look at our pairwise comparisons table to see if those differences are statistically significant. So we, as we have previously, firstly we can look at this row that's got column I anxiety level, column J anxiety level, and we can compare low anxiety to moderate anxiety, and we see there is a mean difference stated. You can either report that mean difference or you could just report the mean for each of those. So when we're comparing low to moderate anxiety level, those two groups, we find we've got a significant difference, a statistically significant difference of 0.028. So those in the moderate anxiety group has statistically higher total worry scores than those in the low anxiety group. Okay, so next, comparing low to high anxiety, participants with low and participants with high anxiety, again we can see a statistically significant difference of 0.038. So what we're seeing here is those with high anxiety had statistically significantly higher total worry scores than those with low anxiety. And the final comparison is to look to see if the medium or moderate anxiety group differs from the high anxiety group, and we can do that by looking at this the second row in column I compared to the fourth row in column J. So the moderate compared to high. In this case, we see we've got a significance of 1. So there is no statistically significant difference between the moderate and high. And I guess we could have worked that out because they're only 0.03 difference between them in terms of the mean scores, 2.023, 2.055. And those two are not statistically significantly different. Okay, so I guess the last thing that's useful to look at, we can ignore, as I said before, we can ignore all the post hoc tests we asked for in relation to the interaction. Is we could look at the plots of means. So this is the main effect for sex, and we can see here females higher mean than males, and we know that's a statistically significant difference from our ANOVA result. This is the main effect for anxiety level, and we know from just looking at the Bonferroni corrected pairwise comparisons table that total worry scores is higher, significantly higher in the moderate condition compared to the low anxiety condition, and in the high anxiety condition compared to low anxiety condition, but there wasn't a significant difference between moderate and high. Okay, and the last plot there, the interaction plot, we can, because we didn't have a significant interaction, you can see there they're not totally parallel, but they're very almost parallel, and you're seeing the same sort of thing. Female scores are always higher than male scores, and on the whole there seems to be this increasing trend or a trend where there's low is different to the other two, but the other two are not necessarily significantly different from each other. Okay, one final thing that I will mention is we interpreted the pairwise comparisons using Bonferroni corrected table, but I did also ask for a post hoc test for Tukey's HSD. And if we look at that for anxiety level, we can look at it using either this table or the one below, this homogeneous subsets. The pairwise comparison is similar to the one we just looked at, but what you'll see is we actually get different results to Bonferroni. So if we just focus on the homogeneous subsets, remember if it's in the same column, they're not significantly different. If they're in different columns, they are significantly different. So if we use Tukey as R, which is a more lenient post hoc test than Bonferroni, remember Bonferroni is quite strict. What we'd have found is that we have a significant difference between the low and high group, but the medium, the moderate anxiety group, is split across the two. So it's not significantly different to the low group, and it isn't significantly different to the high group. So what we're getting is a different interpretation of results. And you'd need to make a decision, really. It's a judgment call as to which you decide beforehand. And the reason I kind of selected this as an extra post hoc test was to sort of illustrate the fact that you can get different results depending on how strict a test you use. I'd have gone with Bonferroni, I think, in this case. And it showed that low was significantly different to moderate and high. But if you use Tukey, Tukey's honestly significant difference, then low is only significantly different to high, but not moderate. Okay, so that's enough for this particular video. It can become a bit overwhelming looking at SPSS output because it gives you so many tables, and it's a case of like figuring out which ones are the ones you need. Okay, so I'll make another of these videos and I'll show you an alternative way to run this type of factorial analysis and obtain simple effects. So I'll do another video where I run an analysis of Factorial ANOVA, but there will actually be a significant interaction, so there'll be more stuff to interpret, and I'll talk through how to interpret the simple effects. Okay, that's enough for now though.